Toothpaste starts with many ingredients arriving at the factory. Every ingredient is checked carefully in the lab to make sure it is clean.
Toothpaste tubes are made from strong, flexible layers of plastic. They are printed, shaped, and fitted with caps. Inside the filling hall,
Animal bones were especially valued.
Across civilizations, from Egypt to Rome to early Asia, tooth powders evolved. Salt.
To understand why these early ingredients were effective, we need to look at the science. Toothpaste relies on abrasives. By the late 1800s and early 1900s, dentistry began to evolve into a science. Tooth powders
Today, toothpaste is more than just a cleaner. It is a precisely engineered formula designed to protect enamel, fight cavities, freshen breath, and remove stains. In this documentary, we travel inside one of the world's most advanced toothpaste production facilities to uncover.
This is the incredible journey from ancient bone powder to modern toothpaste.
Before toothpaste can be created, the ingredients must first arrive. Tanker trucks deliver liquid sweeteners and humectants.
each ingredient is tracked digitally. Every pallet is barcoded, linking it to an internal database that records supplier orders.
One of the most important ingredients is the abrasive mineral, Frabelt, usually hydrated silica or calcium carbonate.
Liquid humectants, such as glycerin and sorbitol, are stored inside sealed stainless steel tanks. Their job is simple.
Fluoride, the key cavity-fighting ingredient, is handled with exceptional precision. Its concentration must be controlled to inners.
Before any ingredient is released to the factory floor, it is tested. Moisture levels, purity.
Approved materials are stored in climate-controlled rooms. Temperature and humidity are carefully monitored because moisture can cause powders to clump.
When the production schedule begins, each ingredient is released for batching, carefully weighed, logged into the system, and transported to the heart of the factory. Toothpaste relies on one critical ingredient, the abrasive mineral. Before it ever enters the mixing tank, it must be engineered to the perfect size.
Raw mineral powder arrives coarse and uneven. Automatic screw feeders transport it steadily.
To create the right texture, toothpaste manufacturers use specialized mills. Ball mills rotate mineral powder. The goal is precision.
Too coarse enamel and abrasives may scratch enamel. Too fine.
Grad other ends of air classifier inside a representative.
But quality cannot rely on sight alone. Samples are sent to the lab, where laser diffraction analyzers. Moisture can cause powder to clump, so before storage, the abrasive is conditioned in controlled.
Now the abrasive is ready, uniform, predictable, safe for enamel. From here, it will travel to the mixing.
This is the heart of the factory, the mixing hall. Here, chemistry and engineering meet.
Transfers. The process begins with purified water. Into this, thickening agents, such as cellulose gums and carbamers, are blended. To disperse these ingredients evenly, high-shear mixers are used. Their blades spin at thousands of revolutions per minute. Next, humectants, such as glycerin and sorbitol, are added. Their job is to hold moisture, preventing the toothpaste from drying out. 3. The prepared abrasive mineral, engineered in the milling hall, is now introduced. Vacuum feeding prevents air.
Then come the functional ingredients. Fluoride, added with extreme precision, strengthens enamel and reduces decay.
And now, the mixture is complete. A blend of water, humectants, abrasives, fluoride, and stabilizers, engineered with precision. At this stage, toothpaste exists as a thick, flowing gel. But before it can be packaged,
High-shear mixers use a rotor stator system. The rotor spins at extremely high speed, forcing material through narrow slots.
during mixing, air becomes trapped inside the paste.
The entire process is computer controlled. Sensors monitor temperature, shear rate, and motor torque, indirect indicators of viscosity.
A final homogenization step fine-tunes the structure, smoothing the paste and aligning its flow behavior.
Once complete, the toothpaste is transferred through sanitary pipelines into sealed holding tanks.
The paste you see here is the result of chemistry, physics, and precision engineering, all working together.
Before toothpaste can leave the factory, it must prove that it is safe, stable, and effective.
From every batch, carefully measured samples are collected. Each container is labeled with time, batch number, and
One of the first tests confirms fluoride content. Using ion-selective electrodes, chemists measure the concentration.
Next, abrasiveness is tested. Toothpaste must remove plaque pores without damaging enamel.
Because toothpaste is used inside the mouth, microbiological purity is essential. Samples are incubated on sterile.
To simulate months or even years of storage, toothpaste is placed inside stability chambers. These chambers... Even appearance is measured scientifically. Experts evaluate gloss, smoothness, and flow.
Only when every test is passed, a quality manager signs the release certificate. Now, the batch is
Before toothpaste can be packaged, it needs a container engineered for both strength and hygiene.
A toothpaste tube may look simple, but it is a layered engineering material. Several thin films are bonded together, including...
The laminated film arrives in giant rolls. It is unwound and passed through high-precision printing units.
The printed film is wrapped around a metal mandrel and heat-sealed along the edge. This creates the familiar hollow tube body. At the top, a rigid head is injection molded from molten polymer. This forms the threaded neck, the part that holds the cap.
Meanwhile, the caps are created on separate molding lines. Once cooled and inspected, robotic systems attach the...
Every batch of tubes undergoes mechanical stress testing. Pressure instruments simulate repeated squeezing, checking for leaks.
Once approved, the finished tubes are transferred to the filling line under controlled conditions.
After passing every laboratory test, the finished toothpaste is released from the holding tanks. From here, first, the empty tubes are oriented upright and gently cleaned using filtered air jets. This prevents even microscopic dust.
Toothpaste is thick, so it is filled using positive displacement piston pumps. These pumps draw a fixed volume of paste with every cycle. A specialized anti-drip cutoff valve stops the flow instantly. Without this feature, toothpaste would smear across the tips. Once filled, the open end of the tube is sealed. Heated crimping jaws press the laminated layers together, melting the
businesses. A laser coder prints the batch number and expiry date. If a problem is ever discovered, even years later, this tiny...
Automated vision systems inspect every tube, confirming correct fill level, perfect seal, and flawless labeling.
And now, the toothpaste is complete. Its journey from raw ingredients to finished tube, guided by chemists. The finished tubes now travel into the automated packaging hall. Here, robotics and optical systems work together. Flat cardboard blanks are folded and sealed using precise droplets of adhesive. Every carton must hold its shape. Once filled, cartons are sealed shut, then coated with the same batch number applied to the tube.
Cartons are grouped into bundles for transport. Heat shrink tunnels apply a film, locking the units together.
Next, palletizing robots arrange bundles into stable layers. Perfect geometry prevents movement during long...
Each pallet is stretch-wrapped, protecting it from moisture and dust. RFID tags and barcodes link every pallet. Finally, the pallets are loaded for distribution. From here, they travel to wholesalers, pharmacies,
Toothpaste is more than routine. Fluoride ions help reinforce epic level. For sensitive teeth, specially designed formulas block microscopic tubules inside dentin, reduce
Whitening pastes use precisely balanced abrasives and chemical chelators, polishing away surface stains without damaging enamel.
Behind every tube, clinical research continues. Dentists and scientists measure cavity reduction, enamel wear, and long-term safety. The future is sustainability. New tube designs explore recyclable multi-layer structure. Factories themselves are evolving. Artificial intelligence predicts maintenance needs. Autonomous robots move material. Yet the true meaning of toothpaste is found here, in daily rituals, morning and night.
The story of toothpaste is a store of innovation, engineering, and care. A small daily habit